As far as the today's class is concerned, today we'll be continuing from the previous class, and today we'll be simply discussing how do we solve the problems of stress and strain in case of the structural members or the machine components which are not uh, linear at all. What I mean by saying is, in the previous class we stated that for machine elements, stress is equal to Young's modulus times the strain. And if we have a machine element in this form, okay, its area of cross section is constant everywhere, it's equal to A, and is subjected to load at its free end, say for example P, then the stress generated in it is equal to P by A. And by the Hooke's law, stress is equal to Young's modulus times the strain, which is equal to change in length divided by the original length. Therefore we can write, therefore we can simply write that P by A is equal to Young's modulus times the change in length divided by the original length. Okay, this is the case for those problems where our area of cross section is constant, okay, wherever A is constant, and the load acting on the machine element happens to be constant. But we often encounter those problems wherein the area of cross section of the member will be varying, as well as the load on the machine element will be varying. How do we find the change in length in case of those machine elements? In order to signify them, let me suppose we are having a prismatic member as is given here. Okay, this member is in the form of a cone. Okay, we are having a cone, it's made of some material. Okay, we are given it a specific weight is gamma. Specific weight means weight per unit volume. Okay, it means weight per unit volume, that is weight divided by volume. So its specific weight is equal to gamma. Now this machine element is not subjected to any external force, but it's being suspended from the ceiling. Okay, that is one of its end is fixed with the ceiling. Now because of the gravitational force, okay, the gravitational force will be pulling this machine element downwards. The question says, how much is the change in length in this case? How much is the change in length in case of a cone suspended from one of the end, fixed at one of the end and suspended from the fixed end because of its own gravitational weight? How much is the change in length? The problem that we encounter in solving these types of questions is that we could directly write the formula that change in length is equal to PL divided by AE from the previous problems. But the question is that as far as our area of cross section is concerned, this is not constant. Okay, this is varying. Okay, this is not constant, this is varying, because you see here the area of cross section here will be pi or not square. You look here, the area of cross section will be different. Look here, the area of cross section will be different. So as we move from one end to another end of the member, the area of cross section keeps on varying. So A is not constant. Number two, talk about the load. As far as the load acting on the machine element is concerned, the load on the machine element is the gravitational weight. Okay, now if you take this much amount of the material, for example, if you take a section out here and consider this much amount of the material, okay, this amount of the material will be having some weight. Let me suppose this portion is having weight W1. Okay, this W1 weight will be pulling the upper portion downwards. That is, the weight W1 will act as the external deforming force for this portion of the machine element. Okay, now as you keep on moving this section, as you go up, as you take a section here, this much amount of the weight will come in. Okay, and the weight of this section will be now equal W2. As you keep on going up and up, the value of the load to which different members are subjected, to which different portions of this element are subjected, keeps on varying. Okay, so as far as the load is concerned, the value of the load acting on the machine element also varies. So in this case, we are having two variables. We are having the variable which is the area of cross section, and another variable is the weight. Okay, or we say the external deforming force. Okay, now in order to solve these types of problems, what we do, let's suppose that as has been done here, let's suppose this is our origin. Okay, and we take this axis to be our x-axis, and we take this axis to be our y-axis. Fine, the radius at this position is given to us, this is equal to r naught. Take a section here, draw a small section here, and you will get a small cone. Isolate that cone, that is here. Okay, the radius here, okay, or let me do it like this, draw a line here. Okay, if you look, the distance from the center to the surface to the outer end is r0 in this case, and is in this case the distance from the center to the outer end here is, say for example, let's treat this as x. Okay, because we are measuring distance in this direction, this is an x direction, this we call as x. Now we have two triangles. One is this right angle triangle, the larger right angle triangle, okay, and the another one is a smaller right angle triangle, that is this right angle triangle. Okay, we are having two right angle triangles, and you see one of their vertex is same, therefore the two triangles will be similar triangles. So we can write from the concept of similar triangles, we can directly write that, and let's suppose this point where we have taken this section, let's take this distance to be as, let's take this distance to be as distance y. Okay, so we can write the x divided by r naught, this is the property of similar triangles, x divided by r naught is equal y divided by L. Okay, therefore from here we can write, which implies the value of x is equal y by L into r naught. So as far as this x is concerned, this x gives us the value of the radius. Fine. How? Look here, if we at, we can do it at x at r sorry at r naught, x is equal to y by L, at y equal to L, at y is equal to L, that is y is equal to L, this is y equal to 0. Okay, let's consider this to be our x-axis, and let's consider this to be our y-axis. Okay, this we consider as our origin. Fine, therefore the distance from here to here is equal to L. Okay, so at y is equal to L, when the value of y is equal to L, what will be the value of x? X will be equal to y is equal to L, so this is L by L into r naught, which is equal r naught, and which is correct. Okay, this is correct here. So this formula gives us the formula x is equal y by L into r naught. Call this as equation first. This gives us the value of this radius. Okay, now we are also given, as far as the volume of the cone is concerned, volume of the cone, that is the portion that we have separated out. Okay, this is this portion that we have separated, where we have drawn this to be equal to x, this portion. Okay, this is separated here. Okay, so look at this separated section. Okay, what will be the volume of the cone? Volume of the cone is given by formula 1 by 3 pi radius of the base, that is pi x square, multiplied by the height, height is y. Okay, therefore volume of this cone is equal 1 by 3 pi x square into y, that's equal 1 by 3 pi, as far as x is concerned, x is equal to y by L into r naught, we are having square and we have our own y. Okay, so if we calculate it, this will come out equal, this is 1 by 3 pi r naught square divided by L square into y cube. This is y square into y, this will be y cube. This is the same result as is given here. So we have the same value of x, and we have the same value of the volume of this cone. Okay, why we are finding the volume of this section? The reason is we are given gamma. Gamma is, it is as specific weight, that is weight of the cone, that is weight of cone divided by volume of the cone, weight of cone divided by volume of cone. Okay, so as far as the specific weight is concerned, look at this section. Okay, this section we have separated here. Okay, it was actually here. So whatever, how much load will be exerted by this section over the above section, over this, that will be equal the weight of the section, and weight is equal specific weight multiplied by volume. Okay, weight of the cone is equal to specific weight multiplied by the volume. So the weight of this portion of the section will be the external load acting on the upper portion. So we will write, therefore the load acting, the force exerted is equal, the force exerted is equal weight of the specific weight, that is gamma, multiplied by the volume of the section. The volume of the section is pi r naught square divided by 3l square multiplied by y cube. Okay, you see, as far as this load is concerned, pi is constant, your gamma is constant, r naught is constant, l is constant, but y is variable. Y varies. Y varies from this end to this end. Okay, therefore your load becomes a function of y. Okay, so now we will also write, as far as the area is concerned, what is the area of the section equal? Area of the section is equal to a is equal to pi x square, which is equal to pi, and x is equal y by L into R naught. So this is this much, which is equal pi R naught square divided by L square into y square. This is area. See, your pi is constant, your R naught is constant, your L is constant, but y is variable. Therefore, A is also a function of y. Fine. So A also becomes the function of L. So what we do, as is done by the question, we'll write the small deformation caused is equal, the deformation caused is equal, let's take, so we have taken a section here at a distance y, wherein the radius is x. Okay, and we say the force that is created by this section is equal to the weight of this section, and it is equal to pi gamma into pi into r naught square divided by 3l square into y cube. Okay, this is the force exerted, and the area of the section, where we are taking this load is equal pi r naught square by L square into y square. This is the area of this section. Now what we do, so we take a small element here, where we have taken the section, take a very small element which has a very small length. Let that length be equal to delta y. Okay, very small length. Let that length be delta y, or let's say the length of that element is very small. Let's take this very small element and say its length is dy. Okay, now this small element dy that is here, let me change the color. The small element dy, the small element we are taking, okay, this is subject to this much amount of the load. Okay, and it is area is this much. Therefore, how much is the change in length? We will directly write the change in length is delta L. It's equal P L divided by AE. This is the formula that we already know. Okay, so for our element, how much is the load acting? The load acting is gamma, okay, pi r naught square divided by 3l square y cube. Okay, how much is the length of this small element that we have taken? We have taken its length to be dy. Okay, divided by area. How much is its area? Its area is pi. Okay, its area is pi r naught square by L square into y square. And how much is the Young's modulus of elasticity? That is E. And this is the change in length in this small element whose length is dy. Therefore, if we can slightly modify, our pi and pi will cancel, our L square and L square will cancel. Okay, our r naught square and r naught square will cancel. Therefore, the change in length will become equal. Therefore, the change in length will become equal, small change in length in this element will become equal, first we have this gamma and we have this 3 and E, that is gamma by 3E, and we have y square and this will cancel, this will be y dy. Okay, so now this becomes very easy for us to understand that as far as the change in length in the small element is concerned, the change in length in the small element selected is concerned is equal, that is we have a small element drawn over here, small element, its length is dy. Okay, therefore the change in length in this small element is equal delta y, which is equal gamma by 3e, okay, y dy. This is the change in length in the small element. What will be the change in length for the entire element? That will be integral of dy. Integral dy, the limit of integration, variable of integration is y goes from 0 to L. So this is L. And total change in length, will write delta y is equal gamma by 3e will come out of integration. Then we have integral y dy, that is y square by 2 going from, that will be L square by 2. Okay, therefore it will become, change in length will be gamma L square by 6e. This is the total change in length. Therefore, under the own influence, under the influence of its weight, this tapered cone, change in length in the tapered cone will be delta y is equal gamma L square by 6 times E, as is being given here. Gamma L square by 6E. Okay, this is how this is to be solved. Gamma L square by 6E is the total change in length. Okay, any questions? Any question? Any questions, students? Hafsa,
नो सर कोई क्वेश्चन नहीं है
can you
सर
understand?
आपने पुराना वाला
Mhm.
जी सर आपने पुराना वाला लेक्चर अपलोड ही नहीं करा यूट्यूब पर अभी
मैं करता हूँ. I will upload that. Don't worry. Okay. Okay. In
थैंक
the
यू
same
सर
way, I am giving you two problems to solve at home. Okay. देखो क्या करना है. Today you will solve two problems very quickly, and I will think of your practicals because we have all the equipment for doing the practical. I will see how we can do the practical. Today you will do two questions. One question is, this is a very important question. You have to solve it. This is a very easy question. We're having a rod of length L and area of cross section A. Okay. Its specific weight is gamma. Its specific weight is equal to gamma. Okay, that is weight per unit volume. It has some weight. Okay, and its Young's modulus of elasticity is E. This rod is suspended from a ceiling. You have to tell me how much is change in length due to its own weight. How much is change in length due to its own weight? You have to solve this question. Okay, so what is this? You have to consider that this rod is having some weight. Okay, and its specific weight is gamma, that is weight per unit volume is gamma. How much is the change in length? How much will be the elongation because of its own weight? Number one question. Number two question that you have to do is, the second question that you'll be doing is, you have again a rod of length L and area of cross section A. Okay, we have a rod of length L and area of cross section A. It is subjected to the force. Now don't consider its weight. Okay, will not consider the deformation because of its weight, but it is subjected to the load W, which is equal to its gravitational weight. Okay, the question is, we are having a rod, it is subjected to the load which is equal to its weight. How much is the change in length? These are two important questions. These are often asked in the gate. First question is that we have a rod, it is suspended from one end. Okay, it is specific weight is gamma. The question says how much is the change in length because of its Because of the gravity. This is question 1. And in this case, we are having a rod. This is suspended again from the ceiling. Its length is L, area of cross section is A. Okay. But now it is subjected to the load which is equal to its weight. How much is the change in length? Please solve both the two questions and keep the notes with you. I may ask you to submit them, but in tomorrow's class, I will ask you how you have solved, what value of change in length you have obtained here, and what value of change in length you have obtained here. Okay. You got both the questions?
Yes, sir.
Please solve both the two questions. Now let me return to what I have to tell you. I have to solve these questions. I had given you few problems that you had to do. Tomorrow I will be solving these preliminary problems, and tomorrow I will be talking about more about this stress and strain. And I hope I can start with the strain transformation. Just a minute. Yes. Okay, that's fine. We are here in the axial load. I have to solve few problems from this axial load concept, thermal stress. Okay, let's see. Please solve these two problems. We'll be taking few more lectures on it before we move forward. But I want all of you to solve as many problems as possible. Tomorrow I will give you more work. And if you have any questions, any problems, you can tell me. Okay?
सर
Okay,
तुम्हारा
sir.
कॉलेज कब खुलेगा?
We don't know. Nothing is no. परसों भी मीटिंग थी लेकिन उसका कोई रिजल्ट ही नहीं आया उस मीटिंग का. Nothing was decided in that meeting. We are actually helpless. It has government has to decide, but they are not deciding. And कभी जैसे उन्होंने schools खोले, we are not certain. I don't know what's happening. पता नहीं. यहाँ से कह रहे हैं SSM कॉलेज ने offline classes start की हैं.
जी सर, एसएसएम वाले जाते हैं और
हाँ,
आईयूएसटी वाले भी.
IOST वाले भी जाते हैं. I don't know.
NIT भी सर 4th मार्च से.
हाँ हाँ 4th March से NIT भी देखते हैं. मुझे लगता है कुछ there are some chances of college opening. I think there are good chances that we may go back, and we are eagerly waiting for the offline classes, particularly in mechanics of materials, because we have to do lots of practicals are there, and we have all the equipment for doing the practical. तो देखते हैं क्या करें. परेशान ही है. अल्लाह ताला रहम करे. परेशान हो गए अब घर में बैठ के, है ना.
हाँ
सर
सर, हो जाते.
हाँ अब बहुत टाइम हुआ. मान लीजिए आप 5 अगस्त 2019 से हम घर में बैठे हैं. लगता है जैसे कल से बैठे हैं. प्रोडक्टिविटी भी कुछ नहीं है. देखते हैं 2 साल में हमने क्या किया. 2 साल में हम लोगों ने कुछ नहीं किया. This is as frustrating for teachers as it's for students. अल्लाह ताला रहम करे. We can only hope and hope. अब the eyes have also given up. अब जो है ना वो आंखों में भी क्रैम्प होते हैं. We cannot focus properly on things. Anyways, Allah ताला रहम करे. क्या करें. So we'll meet tomorrow again at 1 p.m. Okay? Tomorrow I will have your class at 1
Sir,
p.m. Yes.
sir, I have some questions, sir.
Yes, yes.
सर अस्सलाम वालेकुम सर. दिस इज शुएब वानी सर. हमारा अभी रिसेंटली एडमिशन हुआ लेट एंट्री वाले हैं.
जी जी जी
तो एक्चुअली आप इस वक्त चैप्टर 4 पढ़ा रहे
जी
हैं,
जी.
लेकिन पिछले का उस बारे में मैं सोच रहा था कि हम क्या करें.
हाँ जो अभी जो वहाँ पे ना एक्शन लोड पे जो क्वेश्चंस हो रहे हैं, यू
जी सर.
यू यू
जी
यू फोकस ऑन देम. दिस इज वेरी इजी. इनको सॉल्व करने की
जी
आप
सर.
कोशिश कीजिए. ठीक है. मैं जो नेक्स्ट क्लासेस आने वाले हैं मैं उनमें रिपीट करता हूँ पहले. ठीक है. क्योंकि मैं भी अभी पहले 4 चैप्टर्स पे सेटिस्फाई नहीं हूँ कि मैंने इनके साथ जस्टिस की है. ओके. I am
ठीक.
retaking these 4 chapters. Okay. So don't worry about
ओके.
it. So don't worry about it. But be attentive in the class and try to do the homework. Okay. And
यस सर.
focus more and more. Thank you very much. Don't worry. I will look into it. From tomorrow, I am doing questions of all the 4 chapters. So whatever we have studied till now, that will be repeated. Okay.
थैंक यू सर.
Okay.
थैंक.
Allah Hafiz. Any other questions, student? Do solve these problems and I will meet you tomorrow at 1 p.m. Okay. Thank you very much. Allah
Okay.
Hafiz.